here at once. So I changed how I'm going to grade you again, just because we changed to the virtual classroom. So there's a lot of change happening, but it's better for you. So 50% of your grade still is homework assignments, of which you can make corrections on, and I give you feedback if you don't have 100%. Then 20% of your grade is participation. And participation is either being here and being present during the Zoom class, and that's it. Or if you don't attend the Zoom class, there'll either be the option to watch it later on my YouTube channel and take notes and then send those notes to me. Or I might have like something hidden in the video that you need to like do and send to me. So that's how you get your participation grade. I already have today's in Blackboard. It says class 330. So that's today's participation grade. And it says you get full credit if you attend or watch the class video on YouTube and do the participation problems and then email it to me. That'll be in the video today. The last 30% of your grade is any assessments that we have. So that includes the one quiz that we've already had, and that'll include a few more things. If you have any questions on that, go ahead and unmute yourself and then you can ask. You good? Okay, awesome. All right, so I guess that's all I needed to say. We can get started. So what I'm going to do is screen share and then still work through that app that I've been using to make the videos. The issue with that is that I can't really like see you while I'm doing that. So if you do have a question, anytime, please stop me. Go ahead and you can unmute yourself and just ask it. Don't feel bad if you're like interrupting me because I can't see you. So body language isn't a thing on here. So it's okay if you interrupt me. That's fine. Who is this? Who is Terrence? Okay. All right, so let's go to that. So I'm going to screen share. And then if you guys have your books, you can open up to 5-4 in your book. So I have that on here. I have our objective today. And then have your book open to page 337 if you'd like to follow along. Definitely have a unit circle available. Even if you just Google one and have it like next to you somewhere, paper and pencil. I'm not going to, yes, page 337.
Okay.
I'm not going to assign any like official homework today. I'll assign that on Wednesday instead. So all I ask of you today is just follow along, ask questions, just like we're in a regular class. All right. Okay, these are the sum and difference identities. So the main idea behind this section, and this will be the last one that we cover in chapter 5, the main idea is that we are going to find cosine, sine, and tan values of more specific parts on the unit circle, like 15 degrees or 75 degrees or pi over 12, things like that. Things that are not those main spots on the unit circle that we've done. So this is in your book, but I also just screen grabbed something from Google. These are the sum and difference identities. So make sure that you have these written down, but again, they're in your book on page 337 if you don't feel like recopying them. But this is what I am going to be referencing. So I'll give you like a minute if you want to copy them down, and then we'll get into a practice problem. Okay, let's do an example.
Leave it up for a little longer.
It'll still be right here. Is that okay?
Oh, that's perfect.
Awesome. Okay, so our first problem is going to be to find the sine of 75. This is not the one that's in your book, but the one that's in your book as example 1 on page 337 is the sine of 15. I picked an example similar to it, so you would not only have mine to reference, but also the book, just because I don't need to do the exact same thing in there. You guys can read. But if we look at this, you know, we're obviously going to use a sine formula. So let's think about like kind of what we want to do. We could look at 75 as 30 plus 45. I picked those values because those are like the main ones we've been dealing with on the unit circle, right? Like 30, 40, and this is in degrees, so my brain's in degrees right now. 30, 45, 60, 90, and so on, right? There are multiple ways to get 75. You know, we could probably do some sort of subtraction, but the first thing that I think of is, hey, I know the sine of 30 degrees, the cosine of 30 degrees, you know, 30 degrees is a nice friendly value on the unit circle. So is 45 degrees. So we could represent 75 as 30 plus 45. Therefore, that would be using a sum identity for sine. So that's what we're going to do. It doesn't matter which one you make A and B because we're adding. So the order doesn't matter. It obviously would matter with subtraction since that's not commutative. So I'm going to rewrite sine of 75 as the sine of 30 degrees plus 45 degrees. So we rewrote it. And actually, I'm going to write that up top so we have more room. Okay. So A is 30 and B is 45. Again, the order doesn't really matter with adding. So now we're just going to follow this formula, plugging in 30 for A and 45 degrees for B. So we start by doing the sine of 30 degrees. And then we multiply that by the cosine of 45 degrees. You don't really need that dot there if you don't want it, but I'll just show that we're multiplying two things together. Then we're going to add the cosine of 30 times the sine of 45. Again, just following the formula. It is weird teaching to like no sound, not gonna lie. Okay, again, butt in if you have questions. Okay. Remember, sine is the y value and cosine is the x value. So that's why I definitely say reference a unit circle. You know, you're virtually learning at home. You can like use whatever the heck you want. So the sine of 30 degrees would be 1/2 since it's the y value at 30 degrees, right? And then we can just fill in for the rest of these guys. So I'm gonna use the unit circle to reference that. So the sine of 30 is 1/2. The cosine of 45 is √2/2. The cosine of 30 degrees is √3/2. And lastly, the sine of 45 degrees is √2/2. Here's probably like the hardest part. I don't necessarily think that this part's that hard. It's kind of just like plugging and chugging. The hardest part so far has been just recognizing that you can rewrite 75 as this. This also, the algebra is probably another more difficult part because we have to remember just like how to multiply fractions, right? So we're multiplying two fractions, we multiply straight across the numerator, straight across the denominator. So this fraction becomes √2/4. This fraction, right, we can multiply under roots. So √3 times √2 is √6. A lot of you break down roots, right? We know we could break down root 6 into whatever multiplies to 6. So you can go the other way as well. So you can multiply under roots. You couldn't add under roots, just FYI. Like we couldn't add these two together because they're not like roots, but we can multiply them. Multiplying across the denominator gives us again a 4. And then to write it as one fraction, since we do have a common denominator, we could just write it like this, add the numerators together. We cannot add this together to get root 8. That does not work like that. If you ever want to just like see if you can do that, literally plug in root 2 plus root 6 into your calculator, hit enter, see what you get. Then plug in root 8, hit enter. You won't get the same thing. So they're not equivalent, but we can write it as one single fraction because we have common denominators here. So this is our final answer for the value of the sine of 75. Okay, go ahead. If you have a question, feel free to unmute yourself.
This is Dimash.
Yeah, what's up?
Do you think there's like different ways to like solve these? Like sometimes we could do like 120 minus 60, but sometimes we could do like 30 plus 60.
Yeah, for sure. If you end up getting the same value, that would definitely work, right? Like 120, like would there be a different way to get 75? I'm kind of blanking. 120. If anyone sees a different way to get 75 through subtraction, you could. I don't see one, but yeah, sometimes there's more than one way to get something. Like the one in the book, the example is sine of 15, and they got 15 by doing 45 minus 30, but you could get 15 in other ways. Like you could get 15 by doing 135 minus 120.
Yeah.
I think that would just be harder only because you're throwing some negatives into the mix with that. But yeah, there's definitely more than one way to do these for sure. Some might only have one way. Good question. Any other questions? All right, we're gonna move to the next example. This one's tangent. Tangent ones are a little bit crazier, I think, just because take a look at their sum and difference identities. They definitely already have fractions involved in them. And so this one's gonna be a little bit more difficult, but it's still the exact same idea. All right, this one's in radians. So we have to look at our unit circle in radians. Now, to get 7 pi over 12, we need to think about all of these radians as like pi over 12s, right? So pi over 3 would be 4 pi over 12. Pi over 4 is 3 pi over 12. Pi over 6 is 2 pi over 12. So it's thinking about them and how to add them to get 7 pi over 12. Okay, so we can rewrite this as, whoops, the tangent of pi over 3 plus pi over 4. Now that's because, whoops, that's because this right here is 4 pi over 12 if you get a common denominator. And this right here is 3 pi over 12. So when you add them together, you get the 7 pi over 12. So working with radians can be a little more difficult just because radians have fractions like built in, but that is the way that you can rewrite it. Okay, then we're going to use our sum identity for tangent since we're doing plus. So to rewrite that, we're going to use this identity right here. Our a value is pi over 3, and our b value is pi over 4. Again, the order doesn't matter which one we made a and b since we're adding, but that's just how I wrote it. So we're going to have the tangent of pi over 3 plus the tangent of pi over 4, all divided by 1 minus their product. So tan A times tan B. So tan pi over 3 times tan of pi over 4. So both our numerator and denominator have two terms. Our numerator has this term plus this term. Our denominator has a 1 minus this entire term, which needs to be multiplied. So now we can look at our unit circle to figure out what the tangent at each point is, or at each radian rather. At pi over 3, remember tangent's y over x. So it's root 3 over 2 divided by 1/2, which is really root 3 over 1, since the 2's cancel. So this value here is pi over 3, or root 3 rather. This value, pi over 4, when sine and cosine are the same, the tangent's just 1. So we'll replace. So tangent of pi over 3 is root 3. The tangent of pi over 4 is 1. In our denominator, we'll have 1 minus, and then we want to multiply these two things together. This is root 3, this is a 1. So this term, when we multiply, is just root 3. All right. Now from here, we can't write this as a final answer. It's not mathematically like the right way to write things because we do still have a root in the denominator, which we don't like. And in order to get rid of this entire term down here, we're going to multiply by its conjugate. The conjugate is going to be 1 plus root 3. It's just going to be the opposite in the middle here. Whatever we multiply the bottom by, we have to multiply the top by. So we're going to multiply both the bottom and the top by 1 plus root 3. We doing okay so far? Please butt in if you have any questions. All right, I'm just going to throw some parentheses around here because we are going to like FOIL stuff out since we have a binomial times another binomial in both the numerator and the denominator. Okay, so we're going to multiply through. So we're going to do root 3 times 1, which is root 3. Then we're going to do root 3 times root 3, which is plain old 3. Then we're going to multiply through by this 1. So 1 times 1. And last, we'll multiply the 1 times the root 3. So plus another root 3 at the end. In our denominator, when we multiply a conjugate, something by its conjugate rather, the middle terms will end up canceling. So when I go through, we'll do 1 times 1. Next, we'll do 1 times root 3, which is root 3. But then next, we'd have negative root 3 times 1. So those will end up canceling out. I'll still write them anyway, but they'll cancel. Then our last is negative root 3 times root 3, which would end up being a minus 3 at the end. All right, so those middle terms end up canceling. Remember the reason that we multiplied by this conjugate here was to get rid of the root in the denominator, and that happened. So that cancels. So we are left with, in our numerator, when we combine like terms, we have 1 root 3 and another one, so we have 2 of them. And then our constants 3 and 4, or 3 and 1 will combine to 4. And in our denominator, we're left with 1 minus 3, which is negative 2. And then, if you can simplify all three things, right, we can divide both of those by negative 2, essentially. So if we do that, this term divided by negative 2, the 2 and the negative 2 will cancel to a negative 1. And then this term here, the 4 over the negative 2 cancels to a negative 2 or minus 2.
So you're allowed to to divide both of them by -2?
Yes. So like we're technically just rewriting it as two fractions. Because they have a common denominator, you're essentially writing it as this fraction, which this cancels to a -1,
Yeah.
plus this fraction. 4 over -2 is just a -2. So you could think about it like this too before you simplify it. I just rewrote it as, I rewrote this. Sorry, it's a little cramped down here, but here we go. So I rewrote this as two separate fractions and then simplified each one. So this simplified to -√3 and this fraction simplified to a -2. I wanted to come back to you guys because it's weird just talking to a screen. Are we doing okay?
Yeah, I'm all right.
Okay, good.
Yeah.
I like the thumbs up. I miss having you guys in like a classroom. This is like kind of, it's fun though still.
Yeah, we miss you too. We're bored out here.
I'm bored out here.
Yeah.
Aw.
It's getting crazy out here, Mr. Maj.
Well, now you guys get to have virtual class. How's it going so far? How was A period for everyone?
Bad.
It was pretty garbage.
I didn't have A period.
Wow.
Congratulations, Arthur.
Arthur, what is up with your screen?
Yeah,
What's his
that's-
screen? Let's see. I haven't seen it.
Hey, Miles, you still in Florida?
Oh,
Yeah.
wow.
Yeah.
What
Dude,
is
this the
that?
gulag.
It's the gulag.
It
Gulag.
is. You don't know about it, Mr. Maj. It's all right. You too young.
I'm too young. Okay.
Yeah.
All right.
Is that Warzone?
Yeah.
Nah, it's better where yeah. No, I mean it is Warzone, but
Like, look at you trying to like do stuff like
Oh,
that.
you uploaded your own
Hey,
background. That's,
Ethan.
okay, I get it. I was like a little worried about where you were. Not gonna lie. Okay. All right. Okay, let's go back. I have a couple more for you. I'm gonna try to not keep you until 10:50, like a few minutes before, hopefully.
Cody's got a question.
Oh yeah, what's up, Miles?
No, Cody has a question.
Oh, Cody has a question. What's your question, Cody?
Talk then.
We're just doing examples for the rest of the time.
Yes.
Is it okay if I get off a little early? Because my sister needs me for her Zoom meeting.
That's okay.
Oh, Cody.
Cody,
That's
we'll
okay.
miss you. Please have fun. Stay
Just cut
safe.
it and say bye. Interrupt me, okay? Cut it and say bye before you leave.
Yes, ma'am.
Okay.
Arthur, where are
All
you
right.
sitting?
All right.
Oh, meowsy.
Okay, let's get back to our next one here. This one is a U-try problem. So I want to go back to your faces here. So go ahead and write this down, the cosine of 15, and I want you guys to try these. And we'll actually do it on the whiteboard through Zoom instead. I kind of like that. So the cosine of 15, make sure that you either have these written down or you have them just in your book to reference, as well as a unit circle if you need it.
Are you like drawing this with your mouse pad or like?
A little stylus.
Um,
Yeah. It doesn't look as good on here because I'm not as used to this like app. The whiteboard app. So this one's going to use a difference identity, which we haven't done yet. Let me know if you have questions, just butt in. Okay, how do we decide to rewrite 15?
45 degrees minus 30 degrees.
Awesome. Did anybody do it in a different way? Cool. Yeah, it's definitely easiest to, although there, there's other numbers, and Kobe, I think you asked this before, but there's definitely other numbers that will give us 15, but working with values in the first quadrant is probably your best bet just because they're positive. Cool.
30.
Ooh, red. Fun. So here it does matter what A and B are, since it's subtraction. Oops, A and B. Your book uses alpha and beta. It doesn't matter what you use. Okay, in a minute here, I'm going to have some fun and call on some of you. You guys ready? Do we need another minute to keep working?
Yes.
Is there
Yes,
a
okay.
unit circle in our book?
Yeah, I would assume. You know where it probably is a good one is probably in chapter 4 where we first got introduced to it.
Okay, I'm gonna check.
I'll look for it too, let you know the page. There is one on page 248.
240. All right, thank you.
Also mess around with bringing in like pictures to this app here on Zoom, because that would be nice to have it on the screen. Okay, I'm gonna call on some of you here. Cody, what'd you get for cosine 45?
Square root of 2 over 2.
Cool. And Miles, how about the cosine of 30?
Root 3 over 2.
Daniel, sine of 45.
Root 2 over 2.
And John, how about the sine of 30? Just unmute yourself first.
I was muted.
That's okay.
You square root of 3, or square root of 3.
So 30 degrees, look at 30 degrees on your unit circle, and sine is going to be your y value there. Can someone help him out?
1/2. Oh, it would be 1 over 2.
There you go.
Yeah.
Cool. All right, we okay so far? All right, let's do some multiplication. Josh, are you there? There he is.
Yo.
All right. Josh, go ahead and simplify this first term here for us. What do we get when we do root 2 times root 3?
To be honest, I don't know.
Look at the problem.
Hold on.
Okay, look at the problem before.
Root 6 over 2. Nah, root 6 over 4.
Cool. Why is it 4 and not 2?
Because 2 times 2.
All right. And then Arthur, how about our next fraction here? What will we get when we simplify this one? Unmute yourself, bud.
Why don't we just get root 2 over 2?
Oh,
Look at your denominators. We're multiplying. You multiplied the
Oh, correct.
numerators correctly.
Root 2 over 4.
Great.
My bad. Can I get a drink of
Okay.
water real quick?
Yeah, of course. You don't have to ask. It's okay.
Oh, okay.
All right, and then Dylan, how can we write this as one single fraction?
can we just do like root 6 plus root 2 and then just over 4?
Good. Nice job.
Thank you.
All right, that is my PSA to not overcomplicate rewriting things at the end. Please do not put over 8. All right, we're adding fractions. They have a common denominator that's not going to change. These cannot be added together unless you literally just put a plus sign in between them. We can't combine them because they're not like roots. Cool. Okay, we got through that one. Ah. Did anybody just hear that?
Yeah, I mean,
Sorry, that was me. I don't know how to, oh my gosh, okay. All right, let me go back to this other app here. This is our last one to try, but I do want to point out one thing to you guys. If you ever can't make it to a class meeting, if you want to shoot me an email and let me know, that'd be cool. But in order to still earn the participation, this would be like something I would have on the video. This would not be something that anybody would have to do like if you're participating in class. This is just the participation check. So this would be something that you'd send me in lieu of being at the meeting, and it'll vary, you know, class to class, but just FYI, that would be like today's. Okay, this is the last thing I want us to do. Again, I'm gonna do this on the whiteboard on Zoom. So go ahead and get that written down. If you need a unit circle to reference, there's a good one on page 248. And these, if you don't have them written down already, are on page 337, the identities. So sine of 5 pi over 12.
Sister Maj,
What's up?
can I go now?
Yeah.
Okay.
Bye, Cody.
Bye.
Gosh. Okay.
What are you guys all working on? Are a lot of you guys on your phones?
No.
I'm just on my computer.
iPad.
Computer?
Yeah.
Me too. Who said iPad?
I did. Daniel.
There you go.
But yeah. So what was the problem?
What did I have? Sine of 5 pi over 12.
What?
Sine 5 pi over 12. Oh my gosh. All right.
I don't even know where to start.
So if it's helpful for your pi over your like pi stuff, let's rewrite them all as over 12s, right? So this one would be 4 pi over 12, just to rewrite. Pi over 4 rewrites to 3 pi over 12. And
Pi over 6.
pi over 6, and there's more, right? But that's all we need for this one. But you could also rewrite like pi over 2. You know, like all of these radians on the unit circle, they all can be rewritten as something over 12, just because they're nice values that go into 12. Like a clock. Look at that. But you know, you can rewrite and get to 5 pi over 12 just using 2 of these.
Mr. Maj,
What's
Pi
up?
over 3 over
you said it
4.
was sine 5 pi over 12, right?
Yeah, here's the problem. I kind of just discovered this whiteboard after I made all the stuff in the other app, so I might just use this. I don't know. We'll see. Okay, does anyone want to share how they rewrote it first? Like what plus what?
Oh, I did sine pi over 6 times cosine pi over 4 sine pi over 4 times cosine pi over 6.
Cool. You are just like one step ahead. It's great, but can someone share like how we can rewrite it in here, like of what plus what?
Pi over 4
Pi over 6.
plus pi over 6.
Pi over 4 plus pi over 6.
There you go. Okay. Did anybody do it in a different way? Okay. Again, the order can be either way. But pi over 6 is 2/12 pi. Pi over 4 is 3/12 pi. And that adds to 5/12 pi. All right, I'm gonna call on, I don't know, I'll call on a few people that I haven't. I'm just like looking through, I can only see 4 of you at a time right now, so. All right, Mr. Barnes,
Yes.
what did you get for your first line there, like once you wrote out the identity?
Sine over pi over 4 times the cosine of pi over 6 plus the cosine of pi over 4 times the sine of pi over 6.
Awesome. So yours might be like you might have the two terms. There you go. So you might have the two terms just switched in order. It doesn't matter. Again, if you notice here, since it's a sum identity, we can rewrite these in either order.
So is there a way that you know how to put like pi over 6 first?
I just wrote pi over 6 first. I don't know why. I think I heard somebody say pi over 6 first. But you could have written this as pi over 4 plus pi over 6. It doesn't matter. Which I think is that how you wrote it?
Yes. Pi over
Yeah,
4.
that's fine. So I'll redo it there so it looks more like the actual formula. Again, it doesn't matter. You would end up with the same two terms here being added. So either way, you end up getting the same thing. All right, Mr. Fox. What'd you get for the sine of pi over 4?
Root 2 over 2.
Awesome. And then Mr. Morrissey, how about the cosine of pi over 6?
Cosine of pi over 6 would be root 3 over, cosine
Great.
root 3 over 2, yeah.
Good. And then Michael H, what'd you get for the cosine of pi over 4?
Square root of 2 over 2.
Awesome. And Kobe, what'd you get for the sine of pi over 6?
Sine of pi over 6, I got root 3 over 2. Oh wait, I got 1 over 2.
There you go, 1/2. Cool. And then Stash, when we multiply this fraction here, what will we end up getting?
Root 2 over 4.
Okay, awesome. How about for the other one?
Also root 2. Oh wait, hold on. Root 2 or root 6 over 4.
Awesome. And then Phil, what do we get for our final answer, bud?
Like root 6 plus root 2 over 4.
Cool. Awesome. Lots of root 6s, root 2s, 4s in our final answers. I think I called on almost everybody, hopefully. But that's what I have for you today. On Wednesday, we're gonna do like a virtual board work. So we'll kind of work through the whiteboard app on here, and then I'll assign you a couple problems that will be due Friday by the end of the day. And that'll be your assignment for this week. So you're not gonna have as much work because now you're expected to be in class. So I'm gonna kind of compensate it so you're not gonna have an assignment each day.